And we're live. Welcome for this stream. Today we are going to code a trading bot that can copy the trade of a famous trader so that you can make money without doing any analysis. This is going to be a step-by-step coding tutorial. We are going to create a program in Node.js. And yeah, so this is gonna be super exciting. Welcome everybody, I'm Julian. If you are new on this channel, on Eat the Blocks, you'll learn how to become a professional blockchain developer. Let me know where you're from in the chat. All right, so let's get started with a different technology that we're gonna use today. So basically going to use a couple of technology first. We're going to use Node.js in order to create our copy trading bot. We are going to use Solidity, which is a programming language for smart contracts. We're not going to create smart contract, but we are going to read the code of some smart contract. Of course, everything will be on the Ethereum blockchain because when for trading bot, this is one of the best blockchain, as well as all the other blockchain that also use the same technology. We are going to use Ethers.js, which is a JavaScript library to connect to the blockchain. And finally, we are going to use Infura, which is a blockchain API, meaning that it's a service that you can use in order to connect to the blockchain. So that's going to be very, very useful. Okay, and so quick note here. So before we start the coding, so very briefly, I also run a bootcamp to become a Solidity professional. So this is a 1 month bootcamp, and next cohort starts next week. Right, so if you want to register, basically today is the last day. So I'm gonna put the link in the chat, eattheblocks.com/bootcamp. All right, so I see a few people in the chat. Tammy, Alexander, Sean, THX, amazing. Okay, so yeah, so as I said, today we're gonna code this copy trading bot, and really the general idea is that there are some crypto traders out there that are very good at what they do, and so we always want to do like what they do. And the thing is, the blockchain is public, right? So you can see all of the trade of everybody on Etherscan. Okay, any transaction that anybody does, this is accessible on this website. Okay, so for example, let me see. So this is my address. Let me show you some recent transactions. Actually, this is someone who bought the bootcamp here. All right, so you can see basically the transaction hash. So that's the ID of a transaction. You can see if this was a success, which block it was mine, when it was mine, how much was transferred. So you can see the action. You can see the sending address, the recipient address, and so we will analyze this information, and based on that we're going to do the same trade. So of course here the critical factor will be what is the address that we choose to copy. And so for that you will need to spend some time on crypto Twitter to find what are the famous traders out there and try to get their address. But you can also decide to follow some celebrities. So there are some celebrities that use some public addresses, some people who are very famous in crypto, for example. And so if they buy some tokens, then maybe that can give you some indication that it's a good idea to do the same thing. Of course, not every address is doxed, meaning that a lot of people just trade with their address but without displaying publicly what are their addresses. So this technique is not possible for in a lot of use cases. In most cases, you won't even know what is the address of a crypto trader, but there are a number of them that are public, and so that can already give you a lot of indication. Another thing that you can do is, if you want to find some address to copy, you can check out some dashboard like the address that that trade the most. So let me see. I think we have this here in gas tracker. Okay, so we have some statistic about gas spending here. So top 50 gas guzzler. So those are the smart contracts that spend the most gas. And we can also see, let me see. Yeah, we can see the gas spender for the EOA, so externally owned account. Those are addresses that are not smart contracts, so typically owned by people. So here you can see this guy, for example, Jared from Subway, who is a very crypto trader. Probably this is a team actually. You can see that the last 3 hours, they spent 1.55% of all the gas. So those are people who trade very actively. And so that can give you already a first list of people to follow. Some of them here are not interesting. For example, all the exchanges, Binance, 16, 14, we don't care about those ones. But some other like this guy are interesting to follow. Okay. And so now what about the exchanges? Okay, so there are many exchanges, but there are only a few that are really big. So let me see. Let's compare the protocol here on DeFi Llama. And so we want to be on Ethereum. And we want the dexes. Okay, how can we filter the dexes here? All right, anyway, I'm gonna guide you a little bit. So the first one is Uniswap. Okay, first decentralized exchange. This is where we buy and sell token. The second one, Curve Finance. The third one, Convex Finance. Is it a DEX? Not sure. Let me see. Top 10 DEX Ethereum trading volume. Let me see what we can find. Top decentralized exchanges ranked by volume. Okay. So here let's choose Ethereum. Let me see, A, B, C, D, E, Ethereum. Okay, we're gonna have a better ranking here. Yeah, so Uniswap, Curve, Dodo, Uniswap V2, very interesting. There are two versions of Uniswap, and that will be important in our analysis. PancakeSwap, so that's a big exchange on the Binance chain, but they are also deployed on Ethereum. So that is also something that is tricky. Sometimes you have some exchanges that are known for being the biggest on some chain, but they are not deployed just on this chain. They're also deployed on other chains. For example, Uniswap is not just on Ethereum, but also on other chains. A Balancer, etc., SushiSwap. And here what's really interesting is that a lot of those exchanges, they are just copycat of Ethereum, especially a lot of them are copycat of Uniswap. A lot of them copied Uniswap V2. And so that makes our trading bot a little bit easier, because to copy transaction, basically it means that we have less different use cases to cover. But if you already cover Uniswap V2 and Uniswap V3, you already have a lot of different exchanges. The most important exchanges that are covered. Okay, so that's basically the 80-20 principle. Okay, with you just focus on the biggest exchange and Uniswap, and already you will cover a lot of ground. Okay, so this is what we will do. We are going to start the coding. All right, so give me 1 second. All right. So I've created a new project. Okay, so copy bot tutorial, and we're going to create a new npm project. Okay, so npm init y. So now we have our npm is basically the package manager of Node.js. If you never heard of that. Now what we're gonna do is install a few packages that we're gonna need. So npm install, and we're gonna install Ether, so that's the library to connect to the Ethereum blockchain. And we're also going to connect .env, so that's to manage our secret. So here we have two secret, the URL to connect to the blockchain, and then here our a private key, basically. Well, mnemonic, this is a phrase that allow you to generate several private keys. Okay, so here, I'm not going to reveal my real .env where I have my actual secret, but here I have a copy. So mnemonic, here basically you will copy your own mnemonic that you use to generate your address. Then here you will put the WebSocket URL from Infura. So what is this? So you log in to Infura, you create a free account, and it will give you a URL to connect to the Ethereum blockchain. So there are two versions, a HTTP version and a WebSocket one. So those are two different protocols to connect on the internet. And the one we want is the WebSocket version, because with the WebSocket version, we can set up event listener, which means that we're going to ask Infura to tell us whenever there is a new block, and you can only do this when you have a WebSocket, not a URL. So basically you copy paste your WebSocket URL here, your mnemonic, and after that we're gonna create our bot file. So we're gonna call this bot.js. All right, and so we need to set up here some basic thing. We're gonna have everything that happened inside a function, because you need to use the async keyword, and we can only do this within a function in Node.js. All right, so we're gonna just console log trading bot starting, right? And here, so what if we run this like this? Okay, if we run this like this, the problem is that you will see there will be a problem. Not bot. So you just say trading bot starting, but then it ends right away. So our bot is not going to stay online. So in order for our bot to stay online, we're going to do an infinite loop. So we do this with while true. There are nicer way to do this, but this is a quick and dirty way, and it's just going to work. And for every loop, we're going to have a heartbeat. All right. So if you do this, now you're gonna have a problem, because your program is gonna monopolize all the CPU, because it's going to run like crazy. So we need to tell it to calm down a little bit, slow down. So for that, we're gonna define another function that we call timeout. All right. So this is just some utility, and this is with this timeout, we're going to wait. We're going to pause the program. So I'm not going to spend too much time explaining what is the promise in Node.js, but that's basically a way to tell you can tell Node.js to wait until something happens. And so here we're going to use the set timeout function. So that's a function that is going to call another function, a callback function after a certain time. So here, after the number of milliseconds we're going to specify here, it's going to call the resolve function, which is going to resolve our promise. And so we're going to use it like this, use timeout. The timeout is 1000 milliseconds, which is 1 second. So here, every 1 second, we're going to have a new loop. Okay, console log, then wait 1 second, then again. Okay, so let's do this. Heartbeat, 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 heartbeat. Okay, so it's working. So now we just have the basic structure in place, but we need to create another function where the actual logic is taking place. And so this is another function we're gonna call init here. All right, so now let's define this init function here. All right, this is gonna be async also because we're gonna have some we're gonna do some call to the Ethereum blockchain. This is gonna be over the network. Okay, and so now what we want to do there is to subscribe to every new block on the Ethereum blockchain. So you know the structure of a blockchain is basically a series of blocks, and we want to listen to any new block that is incoming. And within those blocks, we will be able to inspect all the transactions and see if there are transactions that interest us. So here, quick note about the general design of a trading bot. We could do something else, which is to set up event listener. So when someone does a transaction on a decentralized exchange like Uniswap, it's going to trigger what we call an event. And what we can do on the client side, so in a bot basically, we can listen to those events and filter them. Now there is a little problem because when you set up an event listener for an event, you need to specify what is the address of the smart contract. And this poses a big problem because we don't know in advance what the smart contract that will be used for trading. And why is that? Okay, so let's take a time here for a schema. Okay, so basically when someone trade on Uniswap, and many other exchanges have the same architecture. So you have a first contract that is called a router. So this is, if you are a user, first you are going to send a transaction to the router. Okay, so here we have a trader, and then this router is going to route your trade to what we called a liquidity pool. Okay. And there are many liquidity pool. Okay, there is one liquidity pool per pair of tokens. So for example, one will be I don't know, wrap Bitcoin, USDC, for example. Another one could be USDT, USDC, etc. You have literally thousands of liquidity pool. All the combination are possible. You have one smart contract per liquidity pool. And so if we want to listen to an event, now we have a big problem because here, let's say this is us. Okay, so you, okay, and you want to set up, so you want to listen to all these events. Okay, so here we are event listener. Okay, and you try to have another one, but you will need to set up as many event listener as there are liquidity pool. And as I said, there are, thousands of this liquidity pool. So it's not really doable. On top of it, there are new liquidity pools that are created all the time. So you also need to keep track of the new liquidity pools that are being created, and this is impossible. And even technically, there's a limited number of WebSockets that you can set up at the same time because each event listener is going to occupy a separate WebSocket. So very quickly, if you have this design, it's not really going to work. Okay, so instead of this, if we just listen to the new block, okay, so here, let me show you here how is it going to look like. So we have the blockchain here with the different block, all right, block, and inside those block, here the this block is related to this one. This block is related to this one, etc. And inside of this block, what we have is a list of transaction. Okay, so in this transaction, we're going to have all the information about what people did. Okay, so we're gonna have transaction 1, transaction 2. So this is what I showed you just before on the blockchain explorer. That was on Etherscan. I show you a very specific transaction, transaction 3, etc. And so now we only need to set up one trading bot, I mean you basically, and we just need to set up one event listener. Okay, here event listener. We just need to set up one, and with this one event listener, we see everything that is happening on the blockchain. And so after, we can inspect each of these transactions and see if we're interested in this one or not. Okay, so this design is much more flexible. Okay, so this is what we're going to do. So back to our code here. So in order to listen to this new block, we need to connect to the blockchain first. Okay, so for that, let's do an import from Ether, the Ethers package. So let's import WebSocket provider, and it's a require statement. All right, so once we have this, then WebSocket provider here, and now we're gonna pass the environment variable for the WebSocket to Infura. So that's RPC mainnet RPC URL WebSocket. Okay, and so now with our provider object, we can connect to the blockchain, and what we can do is set up an event listener for all the new block. We do on block, and then we give it a callback function that's going to be called for every new block. Okay, and now what we can do is console log this block number. Okay, so new block. All right, this is gonna be block number. Okay, so let's run this. Let's see what we have. Oh, what's the problem here? WebSocket closed. Okay, what is my issue here? Why did it close? WebSocket close. Okay, let's init. Okay, should work. I don't know why I say this. WebSocket closed. Okay, what did I forgot? Process. I know, guys. I know. We forgot to this line of code, so we need to populate our environment variable. So the .env package help you to do that, but we need to call the config function to load from our .env file to the process env. Okay. So let's try again. Why you're not? Let me see. Mainnet RPC URL WebSocket. WebSocket. Alexander, the provider on would keep the program running. No, you can try it. It doesn't work. So let's why WebSocket closed. Let me see. I don't get it. I don't see why it doesn't want to WebSocket provider process.env mainnet RPC URL WebSocket. Why it WebSocket closed? Okay, this is not my day, because we're just getting started and I'm already making some crazy error like this. It was just working just before, literally 5 minutes before. What happened? What happened? So let me see. Oh, okay. I think I know. I think I know what happened. Oops. No? Copy bot tutorial. What happened with this? Why it's not working? Let me see. It's not normal. Okay, let me try on my. Just give me 1 second, guys. I'm trying to see on my. Okay, that's super. That's very strange. Basically, the .env file. So I have one terminal that tells me that the .env file is empty, and the other one tells me that it's not empty. So I don't know what's happening here. Why? What is this magic? Guys, that's really crazy. So I have 2 terminals. On one of them, I'm reading exactly the same file, and it tells me that this is empty. Okay, now this one too tells me that this. Okay. It's not safe. Okay, I got it. How are we going to do this? Okay, just 1 second. So I need to do something secret. Okay, I guess that was not safe. So stupid. All right. We are saved. Fuck. Okay, I just showed my API key. Well, I don't care. It's a free one anyway. All right, so now this is working. Heartbeat. And you can see when there's a new block. Okay, so let's see here. We're gonna have a new block. Okay, let's stop it. Now what we can do is we go to Etherscan, and we check that this block number is correct. So he can see this block. It was 17 seconds ago, so that's a very new block. Okay, and so it has 179 transactions. Okay, so this is working. So far, so good. So now what we need to do next thing is, so now we just have the block number. We're not going to get very far from here with this. So we want to know what all the transaction in a block, and for that we are going to use an endpoint that is called eth dot hyphen get block by number. So when you run an Ethereum node, which is the software of Ethereum, you have an API, and this API has a different endpoint, and one of them is if get block by number. This is the one that we want. And so by using Infura, we can directly hit this API. So how are we going to do that? It's very easy. So with the provider, we're going to send a request. Okay, so the name of this request is the name of the endpoint. And then we pass the block number. And after, so this is going to be an array. This is some parameter that I pass to this endpoint. And we have another parameter where if we put true, it will give us the list of transactions. Otherwise, it's just going to give us the metadata of the block, but without the transaction. That's not what we want. So let's do this. And here, wait. So he is not happy because we are missing the async keyword here. All right. And if you do this, it's not going to work because block number is not in the right format. So we want to transform this number into a hexadecimal format. And so for that, there is a special function in a utility of if that is called 2b hex. Okay, so sorry, here 2b hex. But if we do this, it's also not going to work because 2b hex expect a number of the type big int. So big int, sorry. This is a big int is a new kind of number in JavaScript to represent big numbers. So we need to first transform our number into a big int. So for that, let's use the big int constructor like this. Okay. Let's console log the block. All right, so all right, heartbeat. So show me my block. Just doesn't show us the block, so maybe I didn't save the file. Yeah, I probably didn't save the file. I can see here. Okay, let's do it again. All right, so still doesn't want to. That is weird. It seems like it's very strange. Very strange. Okay, good old console log to debug. You know, that's the best way to do it. Okay, so here, that's weird. We have here. So it goes here, and then it gets stuck here. Huh. So it basically doesn't go there. This is what's happening here. It basically stop here, right? That's as if it's just stuck here. And okay, let's see again what's the issue. So provider dot send after is dot under hyphen, sorry, get block by number. That is absolutely correct. And here block number, it is correct too. Okay. Hmm. So this should work perfectly. All right, let me copy from my cheat sheet to see if I did any mistake. So apparently no. I mean, to me, it look exactly the same, right? I'm not crazy. I'm not crazy. So why it stays stuck? Ah, okay. Well, I don't know what I did wrong before. Maybe some typo somewhere. Okay, let's just stop this. So here, let's see what we have in our block. Because we have a ton of stuff. Okay, scroll up. Okay, we cannot even see everything, but here basically this is a list of transaction. Okay, so we have a lot of things, and the most interesting is the transaction. This is what we see here. Okay, so now we're gonna do another call because the block is just one piece of the puzzle, but the other part is the receipt. So a receipt tells you what happened in a transaction. In a what we go in with the block, what we got with this call here is just we see the input of a transaction. So what was the input parameter? But then we want to know the result. And for example, we want to know if the transaction succeeded, because it's possible to fail. And we also want to see the what we call the event logs. So I told you that events this is a data package that is emitted from smart contracts upon certain condition. And one of these conditions is when you do a trade. Actually, I can show you this. In a smart contract. So let me see. Uniswap v2 GitHub pair. All right, so this is the smart contract that we're going to track. And there's a function that is interesting here, which is, let me see, swap. Okay, this is the function that is called when there is a trade on the decentralized exchange. And if you scroll down, you don't need to understand everything. But here, the interesting part is this line, emit swap. This is when we emit an event called swap with different parameter. And under the hood, so here this is Solidity, so you see the emit keyword, but actually at the level of the blockchain, this is what we call a log. Okay, so EVM log, let me see. EVM opcodes, let me show you this. Okay, so this is a list of the elementary instruction that happen on the Ethereum blockchain. And one of them is called log. Okay, so when you emit an event in Solidity, actually at the blockchain level, you're gonna see this thing, log 0, etc. And to get those log, we need the transaction receipt, which is different from what we have here in the block. Okay, so to get this even log, we're gonna get the receipt. So let's define a receipt object, and we're gonna hit another endpoint to get those receipts. And this is going to be is get block receipts. Right, and here as parameter we only need the block number. That's it. Okay, so now let's console log this receipt. Okay, so let's scroll down. All right, and let's run our node once again. So we're gonna have all the receipts. Okay, provider is not, oh, oops. Provider.send, my bad. Let's try again. All right, Tammy is saying it's always a comma or bracket when debugging. Yes. Fulsan, what's the difference between this bot and the one you coded a couple of days ago? Which one? Because I coded many bots. Yeah, please give more detail. Like, what was the title of the other trading bot? But this is the first time that I do a copy trading bot. This is for sure. All right, so do we have, okay, here we have some results. So let's see what we got here. So we see the result of a different transaction. So cumulative gas used, which address sent it. So for example, if you filter by sending address, well, here you can use the from. Oh, no. Okay. This is another nuance. Actually, this is the address of the smart contract that emitted the event. Okay, and that's different from the sender of the transaction. Okay, so I'm gonna show you a schema so that you can understand. All right, so here, let's say you have your famous trader that sent a transaction, and this transaction is gonna land in a first smart contract. This smart contract can emit an event, but it can also call other smart contract like a liquidity pool, which itself can also emit another event. So that means that in a single transaction, you can have several events that are emitted. And so in the receipt logs, this is what I just showed you. When you see the from field, it's not the address of the famous trader, but it's the address of the smart contract that emitted the event. Okay, so it's important to understand that. And here with the logs field, this is where we will see the detail of the different events. So here we see 1, 2, 3, 4, 5, 6. So there were 6 events that were emitted in this transaction. Status, it means that it was successful, 0x1. 2, so that's the first smart contract that received this transaction. So in this case, this would be universal router. And here the transaction hash. So we can copy paste this and see what's happening on the blockchain. All right, so let me see this. So here it was a swap. Let me see. No, sorry. It was an Ether transfer to Eigen layer. Okay, so but it was not a swap. Okay, so we're gonna try others. We're gonna try to find a swap here. All right, what about this one? So here there was some transfer of ERC20, but this is not a swap. So we are interested only in swap. The swap is basically when you buy or sell on a decentralized exchange. Let me see. Okay, so we are not lucky. We don't find any swap. I'm gonna try a few more, but otherwise I'm gonna give up. Okay, transaction hash. No swap. Okay, let me check my note. I'm pretty sure. Okay, yeah. Okay, I do have one save. Don't worry. So here, this is a swap. So we can see that was a success. You can see a transaction action swap here. So swap some narrow token for Ether, and here we can see that this was a swap on a Uniswap v2. Okay, an older version of Uniswap, and so we are going to focus on that kind of transaction because this is where we get some interesting information. We know that someone decided to buy some tokens, so we can have make a reasonable assumption that the thing they bought is a good thing, right? So yeah, we're going to spy on basically the swap of some famous trader, and we're gonna buy the same thing as they buy. Okay. So back to our code. So we have all those receipts, and now we need to do something with them. So we need to, first of all, we need to filter them, because as you can see, here we have all sort of transaction. Okay, we have swaps, but we also have ether transfer. We have any sort of interaction. You also have transaction where there was absolutely no events emitted. So we need to do a first filter. Okay, so let's filter this, and our first criteria, first of all, it's going to be the status. So was it a successful transaction? Because it's possible for a transaction to fail because it hit a revert in a smart contract, which is basically a way to throw an error in a smart contract. So for that, here we need to make sure the status is 1. Okay, and we also want only the receipt where there is logs. Okay, and when there is logs, it tells you that there is an event, and a swap will always emit an event. Well, at least the one of Uniswap, but most likely most swap, all the swaps on all the other exchanges, that will also emit an event. It will not be the same event, but they will still emit an event. So we need some events, so this should be superior to 0. And finally, we also need to filter per trader. Okay, so in our case, because we are still testing, I don't want to filter any trader, but I'm going to show you how you would do it. So to filter any trader, the way you would do it is, first you need to define an array of all the trader that you're going to spy. So here, copy addresses. Okay, and here you would put your different address, 0x, etc., etc. Then another one, and everything between double quote like this. All right. So copy addresses, and it needs to you need to include so receipt from needs to be included in this array. Okay, oh sorry oh no, sorry I'm contradicting myself. This is not the right place to filter. We're going to filter the copy address after. Okay, so here we have applied our first filter. Okay, then we're going to loop through those receipts. So for that, we're gonna have a for loop. Okay, so we could also use for each, but actually no, because for each doesn't allow you to execute, to use the await keyword inside. So we need the await keyword. And now we also need to find the corresponding transaction to those receipts. Okay, so block transactions, and in those transactions, how are we going to map them to the receipt? It's easy. So we're going to map them according to the transaction hash. Okay, so the transaction hash needs to match here the one of the receipt. Okay, and what else? What else that we need? Let me see. Yeah, so here basically we are looping, and for each receipt, we're going to see if this transaction is, we find a transaction that matches the receipt. So now what we can do is we can filter according to the copy address. so actually we're going to filter according to different things. So if we don't find the transaction, so it's almost impossible. Okay, if you basically here we get the block, we get the receipt of the same block. So we need to find the transaction that match all the receipt inside. There is a tiny chance that there is a discrepancy if when we hit the API of Infura, let's say that, so internally your call might be dispatched to a different nodes, and maybe for one API call there is one node that is slightly that is not synced with another node, and so during your next API call it hits another node, and this one doesn't have exactly the same data as the first one, but it would be extremely rare. So in most cases you will find a transaction. If there is no transaction to field, so no recipient to this transaction, it means this is a deployment transaction. When we create a new smart contract, we send a transaction without a to field. In this case, we are sure this is not a swap, so we also don't want that. And finally, if transaction from, if this is not included in copy addresses, okay. If this is not included, we are going to continue and basically go to the next transaction because we are sure that this transaction is not the one we're interested. In our case, as I said, for testing, let's not use this because otherwise it makes it more difficult, right? Okay, so now we have some tests. Next, we will need to we will need to find what is the decentralized exchange that was used in this transaction. But it's so how are we going to do this? Because not all of this transaction will be for swap. We're only interested in swap. So there's a very simple method to filter a decentralized exchange transaction. We want the transaction 2. This needs to point to the smart contract of a DEX. Okay, and it turns out in most DEXs, their entry point smart contract is called a router, as I explained. So transaction 2, if it doesn't point to a router that we know, then we're not interested in that. So we're gonna need some configuration file. Okay, so blockchain.json. And let's define a DEX's key. Okay, and in this DEX's key, actually this is going to be an array of DEXs. Inside we're going to have different entry, and so first let's do router address, and we are going to put first the router of Uniswap. Okay, so let's see on Etherscan. This is a transaction that uses Uniswap, and here it's a little bit tricky because the entry point is not V3, it's not V2. It's called Universal Router, which is a modern router which can dispatch transaction both on Uniswap V2 and V3. Okay, but the address we want is this one, Uniswap Universal Router. So here we have a first DEX that uses this router. Okay, so now let's import this. So let me see. Blockchain require blockchain.json. Okay, and now let's filter our receipts. So how are we going to do this? Blockchain.dexes, and we want to find an entry where dex router matches. So first of all, let's put it to lowercase, because there are different format of address. They don't always have the same case. So let's put everything lowercase. Transaction to lowercase. Okay, let's get this dex. And if we don't find a dex here, it means that the transaction is, we're not interested in this transaction. This is not a swap, or at least not a swap that we can understand. Okay, so if no dex, continue. Otherwise, what we're gonna do is let's just console log transaction hash. Okay, so we can already check that if what we're doing is working. Right, so heartbeat, we are waiting for some up. Some, what's the problem here? Cannot read property of undefined. Okay, so what is receipt status? Okay, here I have an S. Okay, a little typo. Okay, let's run this again. So it's gonna show us a list of transaction hash, and all of them should be swap. So here's not router, but router address. Okay, just some typical typo. Okay, let's see. Okay, so now we have a ton of transactions. So let's check that one, for example. And see what is this. So Uniswap router. Okay, very good. Let's pick another one. This one, for example. This one is also Uniswap router. Okay, and the last one. This one. Just making sure that this is working. Uniswap router. Okay, so we are selecting all the transactions that are sent to the router. Very good. So next, what we need to do is we need to configure a set of pools, because right now we've just identified that this is a transaction that use Uniswap router, but the type of pool can be different. It can be V2 or V3, or in the future, once Uniswap V4 is released, now we'll have even more type of pool. So we need to define a pools entry. So this is for Uniswap, it's a little bit more complex, but for other exchanges, in most cases, you have, for one type of router, you have one type of pool, so the algorithm is will be slightly easier. So let's define an array of pools in, so first of all, let's call this Uniswap V2, because we are going to track the swap on Uniswap V2, because actually a lot of trade is still on Uniswap V2. Okay, and what else that we need? Let me see. Okay, and we need to define the ABI. Oops, it's here. we need to define the ABI of the event that need to define the ABI of the liquidity pool on Uniswap. So I'm going to explain what it is. Okay, so the ABI is a representation of the interface of a smart contract, and it allows ethers to know how to interact with a smart contract. And so, for example, in an ABI, we have the different events of a smart contract. So I showed you before that here the swap event of liquidity of a pair on Uniswap v2. So we need to find the definition of that. Let me see. Interfaces Uniswap v2 pair. So this is probably here. Interfaces Uniswap v2 pair. Okay. And event swap. Yeah, this is what we want. So let's copy paste this. All right. And now let's just put it on its own line. I guess a bit annoying to do. And so with this, we will be able to decode the logs and see the swap event. Okay, almost done. Please bear with me. It's there. Right, so we need to close this array. Very good. And what else? All right, so now we have our ABI. So let's go back to the trading bot. And let's loop through all the logs of the receipt. So for all the liquidity pool that we have in a blockchain.json, all the type of pool, sorry. First of all, we're going to define what's called a pool interface. Okay, we're going to need this to decode the swap event, and we pass it the pool ABI. And this interface, we get it from ethers. All right. And now with our pool interface, what we're going to do is we're going to transform the logs that are basically not really human readable. This is some low-level representation of an event. And so we're going to transform this in a representation that is more useful for our trading bot. And for that, we're going to pass our pool interface we've just defined, and I'm going to pass the log. All right. And after, we're going to have a list of events. But the thing is, so this pool interface is only able to pass the events that have this shape. And we also know that this originated from a transaction that targeted this router. So even though this event can be defined on any smart contract, because the transaction started here, we are sure that in this case, this will come from a liquidity pool. Okay, so we understand that this is a swap, basically. So if this is a swap, we are going to see an entry here. Otherwise, this is going to be a null entry. Okay, so let's console log the event to understand that. Okay. All right, so little problem here. So what Oh, no, not receipt with the S, with the, there's no S here. Little typo. Let's start again. All right, so let me see. Oh, cool. So we got some. Okay, so here we have something. So for example, here in this is a transaction where we did not recognize anything. So it was probably not a swap. Here, this is, okay, so details of the invalid fragment. Let me see. Okay, we probably have a problem in our configuration. Let me see. I think we are missing the closing parenthesis. Yes. Okay, so let's try again. Because we shouldn't see this warning if everything is correct. So, okay, so now it's better. So let's see. No, so this one is not a swap, not a swap. But here, this is a swap. Okay, name swap. And then after you can see some detail. So here, these are the detail of the swap. So this address here, let me see. This is the address of the sender of this swap. Okay. Then this number here is the number of token that was provided in input. And the n that you see at the end, this is because the representation of this is a big int. So it's actually not the number that you think. It's in decimal. I mean, a normal number probably would be different from this one. This is a notation for big number. This one is the other token that is provided in input. So here, of course, we provide only one of them in input. So the first one has the two inputs, so token 0, token 1 of input. And then the next two one are token out of input. So so here we got this one, the second token in output, that's the number that we see. And finally here, this address is the recipient of the transaction, of the swap. So if you do a swap, in most cases 2 is going to be the same as sender, but you don't have to. It can be another address. All right. So now we're making some progress. We can analyze those events. So now we need to filter the one that are swap. So, and the swap of Uniswap v2 especially. So Uniswap v2, if event length, let me see. So when this is a swap, the event length is going to be at least 5. And the events that is going to be the 5th event of the transaction. So that's this index 4. And so here that means we have something not null, okay? If we have something not null, it means we were able to pass this event, so this is a swap. And finally, if the pool type in our configuration is Uniswap v2, okay. So we're gonna have our logic for the copy trade inside. And so for each new type of DEX that you try, you're gonna have a new if statement. So Uniswap v3, so maybe probably the event length might be a little bit different. Maybe it's not going to be event false, but maybe it's going to be the 5th one. And here it's going to be a different configuration. So you're gonna have another entry in your blockchain.json. So this is how you would add new exchanges. But let's just focus on Uniswap v2. All right. So we want to we want to print some details about this trade, or say, okay, so we want to say, hey, we found a swap. Okay. So for that, let me see. What do we need to? So first, actually, we need to connect to this liquidity pool because we're still missing some information. Okay, so let's define a JavaScript object that points to the smart contract. We're gonna use the contract object of ethers. Okay, so here, let's go. And inside receipt.log for, okay, so first we need the address of the contract and the address of the pool, so we can see it. Yeah, let me see. Fragment. Yeah, so actually this is not in the events object, but this is in the logs. Where is it? Yeah, in receipt.logs, okay. The fifth entry basically give you the smart contract that emitted the event. Okay, so this is how we can know the correct address. Let me see, dot address. Now we want to have the ABI also of the contract so that we can connect to it. And finally, we need what's called we need the provider. All right. So pool ABI, actually, we need to add something into it because we need to call other functions. So let's go back to v2 Uniswap. Let's go back to the definition of the Uniswap v2. And so this Uniswap v2, this is also an ERC20 contract. Okay, so you can see it here, but yeah, no, this. Okay, no, this is not relevant to what I'm about to say. Forget about this. It doesn't matter. What does matter is that these two public variables here, token 0 and token 1, and those are the addresses of the two token of this pair. Okay, so this one could be USDC, this one could be wrap Bitcoin, etc. But we need to know what are those two addresses. And so because they are public variable, there is a getter function of the same name that is already defined. Okay, so token 0 is we want to execute token 0, but let's find the interface. Let me see. Let's find the interface for this here. Token 0, where is it? Okay, these two. Let's copy those. All right. And now our ABI is complete for Uniswap v2, so we will be able to read token 0 and 1. So let's do this. Promise all. So we're gonna call two functions at the same time. All right, pool contract token 0 and the other one token 1. So this is how you can execute smart contract function that are read-only. Okay, and we execute both at the same time thanks to promise.all. All right, and now we need to determine what is the token that is sold and what is the token that is bought. So first of all, let's isolate the swap event. So swap event. All right. And then, so token in is basically the token that we sell. And how are we going to determine this one? Well, swap event.args. And so here, if the first field of the event is swap, let me see. It's not the first. This is the second field of the event that tells you the amount of token 0 that has been provided as input. So if there is no token 0 that is provided as input, it means that we must have provided the other token as input, which is token 1. Otherwise, if it's not 0, so that means what we're selling is token 0. All right, and here why there is an n, because here this quantity is going to be in a big number format, so we need to compare it with another big number. Okay, so now to get the token out, we're going to do the contrary operation. If let me see, in this case it's going to be the contrary, token 1, token 0, and token 1. Okay. Then what about, next we need to exclude certain token, okay, because we need to exclude the swap that will buy, for example, some stable coin, because we don't care about the buying signal for stable coin. Also wrapped, so probably, all the stable coin, we need to exclude them. So let's define this. Let's define an exclude list. So we're gonna call this excluded let me see, excluded tokens. All right, so what we want here, we want probably USDT. I want probably USDC and the DAI, because they are the biggest stable coin. Okay, so here I'm going to copy paste these different addresses. So USDT, it's this one. USDC. Keep in mind that I'm doing this configuration for Ethereum mainnet. Might not be the same addresses for other blockchain. DAI is this one. All right, so we don't want to buy stablecoin. Makes sense. So now let's do if excluded token includes token at, which is the token that we're buying. In this case, what we're going to do is we're going to break out of the loop. Okay. Break. So let me see. So basically here we are in inspecting a transaction, and so we don't even need to see. We can basically go to the next transaction, because we know that this is not something we want to copy paste. This is why we break it here. All right, so now we're going to console log the detail of this trade. So console log swap found. All right. All right, then let's put the transaction hash. Transaction hash. All right. What else? From. Yeah, so the sender. What else? Router type. So let me see. Do we have this configuration? I'm not sure. No. Router type. So that's how are we going to call this? This universal router. Okay. Then pool type. All right, and token out. So that's token out, and then token sold. That's the country. Token in. All right, and yeah, so let's do this. Let's run this, see if we have any error. All right, very cool. We have a lot of information here. For example, this transaction is supposed to be, the token bot is 0xc and the other one is 0x5. Oh, no. Okay. Problem here. It's not bot, it's sold. Okay, let's see if this is true. So check with Etherscan. So we find the transaction, which is good, and it's swapping, it's selling some Fuku token for Ether, so which is represented by wrapped Ether. All right. Let me see. Okay, so wrap Ether, this is this address 0xc02. It's wrap Ether. That's an ERC20 representation of Ether. So that's the token bot. And below, this is here's the typo, it should be sold. 0x5 something. So it should be this Fuku token 0x5 something. Yes. So that is working. Amazing. So we are able to extract the swap. So it's amazing. Now the last part, and which actually isn't the easiest, is to copy the trade. So to do the same thing, and we have different options here. We could, at this point, we could just save this in a database, for example, and every day we check the database and manually we decide to copy this trade or not. Could send ourselves an email, for example, by using the API of SendGrid, so that there's this manual step. And this is probably the safest. But if you want to have something even more sophisticated, you could also do the purchase automatically without any human interference. And so this is what we are going to do after. So for that, you have a choice, because here we used the universal router of Uniswap, which is a new thing, okay? And it's a bit more complex. But we could also use the router of Uniswap v2, which is way more simple. But you know what? I decided to make it complex. So we're gonna use the router. But I'm half kidding, because once you know how to do it with, we're gonna do it with the universal router, sorry. But once you know how to do it with the universal router, well, guess what? You can also handle swap that are coming from Uniswap v3, okay? So we're not wasting our time. We're basically making it easier to handle different kind of swap here. Okay, so actually I'm gonna take a quick water break, okay, and see what we have in the chat. So are you guys still here? If you are still alive, let me know in the chat. Mr. Ice Freeze, how it's going, man? I'm a little late to the party. It's just about to start. The best moment is about to start, which is the how to interact with the universal router of Uniswap. This is gonna be very fun. All right, why make it simple when you can make it complicated, right? It's not fun. All right, some people are still alive. Very good. Not everybody is dead. Very good. Full San, Alexander in that place. All right, so what is this universal router thing? So universal router, that's a new smart contract that is supposed a unique entry point to different kind of liquidity pool. So it can process transaction both for Uniswap v2 but also v3, and probably that in the future when v4 will be released, I'm sure we will still be able to use this smart contract. And so the gist of it is that you have this function execute, where you're going to pass a series of commands and an array with the different inputs. So this is the argument for those different commands. And then this contract is going to dispatch it to the correct liquidity pool. And so for the command, this is a bytes variable, and you have different commands that are identified by hexadecimal numbers. So for example, if you want to use Uniswap v3, that's this one. If you want to use Uniswap v2, is this one, etc. And to make it even more interesting, they added also something else that is called permit2. So that's a smart contract to simplify the approval mechanism, because the problem at the moment is that every time you trade with a new liquidity pool, you need to do two transactions. A first one to approve your token to be spent, and a second one to actually do the transfer. And so in terms of user experience, it's not great because it's more complex for user and it also costs more money. So what if we could reduce this number of steps? So that's the object of permit 2. So this is related to a standard. It's called EIP 712. And this involves signature. So we're not going to go into detail, but I'm going to explain in a simple way how it works. So first of all, you have our beloved user Alice, who is going to approve a smart contract called permit2 to spend all her token. Okay, you give it max approval, but that's the smart contract that is approved. So you know in advance the code of the contract. Okay, so if you trust the code of the contract, it should be fine. And now every time you want to do a swap or any protocol that needs to do a delegated transfer for your token, you're gonna do a signature off chain, okay? Then you're gonna put this signature inside your transaction, and the protocol contract, instead of getting the token directly, which will not work because you will need to approve it for that, but you never approve this one, okay? Because that could be the first time you interact with it. If the smart contract works with permit2, it's going to ask permit2 to transfer your token, and it's going to give it the signature. Permit2 is going to verify this signature, and this signature will authorize specifically this protocol contract to spend the token. If everything is correct, then basically Pyramid 2 is going to get the token to itself, then forward the token to the protocol contract. Okay, and so with this, instead of many approval, you just have one approve. So this is the idea of Pyramid 2, and for universal router we need to use Pyramid 2. Okay, so I told you that here there are different commands. So one command we're going to use is v2 swap exact in, which is a command to trade on Uniswap v2. But we're also going to use permit here, this one, okay, which is a command to ask the token from permit 2. All right. So we are going to we're going to get started with this. So here, let's do this. If let me see. If the router type is Uniswap v3, so first of all, approve the permit 2 contract. So actually we don't need to do it every time. We can only do it once. So we can create like a sort of how do you say, an initialization code that run only once, and after we don't need to approve it again. But here let's just make it simple. And after, you need to sign the permit 2 message. And finally, you need to swap, do the token swap. All right, so let's get started. So let's do the first thing, the approval. So for that, we need to have a pointer to the token in contract. That's the token that we are going to use for paying. Okay, so new contract, and actually we don't need to use the same token in that from compared to the transaction. Okay, we can choose whatever currency we want to pay, because what we're interested in is the token we're going to buy, but the token we use to buy it, we choose it. So for example, we could define which token we use to buy, because we also need to make sure that our balance is regularly replenished, okay, because this balance is going to go down. So token in address, and we are going to use for example, wrap ether, which is this one. All right, so wrap ether, and here for the contract, so first thing to pass is the address, so that's going to be token in. Then we need the ABI for ERC20 token. So let's define this in blockchain.json. ERC20 ABI. Okay, we don't need everything. We're just gonna, let me see. Okay, so open zip link, GitHub, ERC20. This is a library for Solidity, and this is very used to implement ERC20. And so we only need this in the ABI, the approval function. All right, so let's put it this way. All right, back to bot.js. All right, and lastly, so here, provider, okay. And after that, token in contract approve. So we're going to do an approval. And we're going to approve permit to address. So that's the address of permit to. So where this is going to be stored in our DEX. Okay, so here, permit to address, and where is this? Let me find this in my note. Permit to address. You can find it on Etherscan, this one. Okay. And after, we need to specify how much we want to approve. So let's approve the maximum. And we have access to the maximum in a constant object of Ether. So constants.max uint 256. Okay, and so let's import this. Constants. All right. So let's send this transaction, approve transaction. And we also need to wait for the transaction to be mined. Await, approve transaction, wait. Okay, so approve receipt. And now let's make sure that this approval worked. So approve receipt status. And if this is different from this value, it means that it failed. So we're just going to stop here. Okay. Couldn't copy trade. Approval failed. Okay. And let's just show the transaction. Okay, because we probably want to investigate why it failed. Approved receipt transaction hash. All right, so if we reach and we want to go to the next transaction, so let's break out of the loop. All right, so now we have our approval. So the next step is to sign the permit to message. So this is a one-time signing. You need to sign this for every swap that you do. Okay, and for that, first of all, we need to fetch an information from the permit to smart contract. Okay, so let's define a new variable. Const permit to new contract permit to address, and we need also the ABI of permit to. So let's define this. ABI. All right. So let me see. Okay, this is the definition of, this is the code of permit2. And the one we want, let me see. Can I find it here? Allowance, let me see. We need to find the allowance function. Where is this? Allowance function. Maybe an interface somewhere. It's not this. Oh, okay, this one. Yes. Okay, so let's copy this and back to here. All right. Oops. Okay, so this is all we need. Sorry. Then we need to pass the provider here. Okay, permit2. Then what we're gonna get from this permit2 contract is the allowance. So permit2 dot allowance, and we pass the. Oops. Okay, so actually here we want to know the address of the. We want to know our address, and so for that we are missing something. We are missing a wallet. So let's. So how are we going to get the wallet here? Wallet equal from phrase, and here we're going to read from our mnemonic. So you should always keep this secret, all right? And we pass also the provider. And now with our signer, we can actually send transaction, okay? And we can also get our address, because this is what we need here. Okay, so next we need to know what is the, we need to know the address of the token that we're going to use for payment. So token in address. Okay, we've already defined it before. That's in our case, this is going to be wrap ether, but it can be anything you want. And what's the address of the spender, the router address? Okay, so let's get this value, and after, once we get this value, we want a field called the nonce. Okay, so the way permit2 is structured is that you have a nonce for any combination of a wallet address, the asset you're going to spend, and what is going to be the spender. All right, so after here, I'm going to show you. Ultimately, we want to execute this function. So signature await wallet. And here we're going to use a function that is still considered experimental, but that's an implementation of EIP 712, sign type data. So there are different functions in ethers for signing, but this is the one we want. And we're going to need different things. So let me see. So first of all, there is something called EIP 712 domain. Okay, so this one is not too complex. EIP. Ah, it's not 721, it's 712. Domain. This is an object where first we have the name, so smart contract is permit2. The chain ID, so this is a number that identifies each blockchain. We haven't defined it yet, so let's do it here. Chain. Yeah, chain ID. All right. And how do I know that this is one? Well, that's because you can go on chainlist.org, and here you can see for Ethereum mainnet, you can see the chain ID, that's 1. Okay, so this is this number. And finally, for this, we need another field called verifying contract. And this is going to be the address of permit2. All right. So someone mentioned that we should filter wrap ether. It depends. Like if you trust this trader to give you good signal to buy ether, in this case you want to let it, but most likely you want to follow this trader for smaller coin, right? So yeah, maybe you can include as well. So permit2 address. Okay, we have this parameter. Next, we have other things to pass to our wallet here. We have, let me see. We have something called permit to permit type. Okay, so permit to. Okay, so I'm going to show you how it looks like. Permit to permit type. So it's a bit annoying because that's Uniswap v3 is really more complex, but it's just the way it is. But fortunately, I've already done most of the work for you. Okay, so it's more simple. And this is this thing. Okay. So that's basically some configuration for permit2 that we need. All right, so and here I put it for my DEX because this is specific to the universal router. So for example, if you use another router of another DEX, they might not use permit2. We might not use this configuration. Okay, so let's go back to our code. And finally, we need an object called permit that is going to define specifically the address that we want and what's the amount also that we want. Okay, so for that, let's define this permit. And first, there's the detail key. So token in address. Now we also need to define the amount. So let's make it simple and let's buy the same amount every time. All right. So here, let's do token in amount. And for the amount, let's do all right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So it's going to be 0.1 ETH. So at the moment of recording this video, that means it's roughly $250. Okay, so token in, let me see here, token in amount. What else do we need? We need the expiration. Each signature has an expiration. So for this, what we can do is let's get the current, the timestamp for the current block, okay? And we're gonna add 5 minutes, okay? So 60 times 5, okay? That should be enough. Then we also need the nonce for permit 2. So that's this variable that this value that we got just before. Now we also need the spender. So the spender is going to be the router address, and then the deadline. So I don't know why there's both an expiration for here and also here, but here I just put the same. Okay, so now we have permit, and now we have our signature. Okay, so that was difficult, but don't worry, because after that it's going to be even more difficult. So now that we have this, let me see where we are going to start. Okay. Okay, I think I know. So I'm going to first show you what our swap transaction is going to look like. Swap transaction. So first of all, let's connect to the router. New contract, DEX router address, then DEX router ABI. So I don't think we have this configuration yet. No, so let's do here router ABI. And what do we want for the router ABI? We just want the execute function. Okay, so oops. Let's go in the definition of the router. Okay, so we have two execute function here, and which one are we going to take? Let me see. So we have one with a deadline. Okay, so that's the one that we're gonna have. So let's copy paste this. Okay. Function execute. All right, so that's fine. Let's back to the bot, router ABI. And finally, we want our wallet. So this time we don't pass the provider, but we pass the wallet because we actually need to sign the transaction, and for that we need the wallet. Okay. Next, let's define our swap transaction. So router, and here we don't want to use the execute function like this because in this contract there are two versions of execute. So to be really specific, we use another way of calling function by their signature, like this. Let me see. Execute and bytes array. The second one is a bytes array. And finally, the last one is the deadline. Okay. So the first argument, bytes, this is going to be a series of commands. So first permit to, and then do the swap. And this bytes array, this is going to be an array of the different arguments for the two commands on the left. And finally, the expiration for the swap. Okay. And after we pass the argument, so the list of command, encoded input and expiration. Okay. And after we wait that this transaction is mine, and like before, if this is, so first of all, if this is successful, prove receipt status DOX1. Okay. Successfully copy trade. Console log. Let's show the transaction hash. Swap receipt dot. Right. Otherwise, if this is not successful, let's put an error message. Couldn't copy trade, swap failed. Okay. And after all of this, we are ready to, we're gonna break out of the loop, because we need to process the next transaction. So we might have other code after that, like if for the other, if dex type equal, I don't know, sushi swap, etc. But so the code likely will not stop here, okay? But for ourselves, this is gonna be the end. Okay, so now we need to create these two parameter commands and encoded input. Okay, so how are we going to do that? So first of all, let's do commands. Okay, so first of all, let's define the individual command, permit to permit command, and this one, so we need it in hexadecimal, permit to command. So we have it here. Okay, so it's here basically. And we're not going to put double quotes here, but we're going to enter it directly like this, and JavaScript knows how to interpret this as an hexadecimal. And then the second command is v2 swap exact in command. Okay, and v2 swap exact in, so that's here. All right, now let's define an array with our two commands. And now we're going to transform this array into a byte string. So how are we going to do that? Actually, here we're going to use the reduce function. So to transform this array into a single value, okay, so here something. So the initial value we're going to start with is 0x. Okay, that's going to be the end, the beginning of our byte string for the command. Okay. Then, and so the first value of the accumulator is going to be 0x. And here we're going to concatenate this. So accumulator dot concatenate with the new command. And we're going to transform this hexadecimal number into a string. And so that to help JavaScript understand, we're going to tell it that this number is the radix. Basically, this is a 16. This is a hexadecimal number. All right. And then we're going to pad it at the start with 20, because this is in the documentation of the universal router. All right, so now we have our commands. And finally, we need the encoded input. Okay, so we're almost done, okay, but still need, still need to follow with me 1 second. All right, so the encoded input look like this. Encoded inputs. This is an array, and in this array, we are going to encode basically ABI of command input. The general shape of it is going to be something like this. ABI of command input. So when we say ABI of command, that's because each of these command is going to trigger the function, another smart contract. So you have first it goes to the universal router, and then universal router is going to forward this to another contract, and it's going to execute a function on this other contract. So first one will be permit2, and then it will be the swap. So we need the ABI of each function basically, and here the input, basically the actual value that we will have. Okay, so let's do it step by step. First of all, where do we get this encode function? So this encode function, we get it from something called ABI coder, and we're gonna get this from ethers. By the way, if you find this difficult, it's normal. It is difficult. Uniswap v3 is not a simple protocol. Okay, so ABI coder, we get it from here. Okay, let's go back. Yeah, all right, perfect. So now ABI coder.encode, ABI coder.encode. Okay, and so now let's replace this permit2 permit ABI. All right, so let's define this. Permit2 permit ABI. All right, so it's going to be this. So first we're going to have a struct, and this struct is going to have this shape, token, amount, expiration, etc. And then the second parameter is going to be a byte. Okay, well actually we can see this in the smart contract of permit 2. So let me see. Permit, where is it? Yeah. Yeah, permit single. So I think this is the correct one. Let me see. Permit single, yes. And here, so we have the bytes, permit single. Let me see. Let me see this struct. So permit single, where is it? Permit a struct, and inside there is another struct. So permit detail. Yeah, okay. So you can see all this information here. So the token, the amount, the expiration, nonce, etc. And so you find all of this on this line, and then you have the bytes. Okay, and for this one, it's going to be a little bit more simple. V2 swap exact in ABI. ABI, all right. And what is it going to be? All right, so let's go. Okay, this is not here. So Uniswap v2 periphery. All right, and swap exact token. Let me see. Should be here. Swap exact token for token. Let me see. Is it this one? Okay, so actually here, this is swap exact token. I don't find. Okay, so this is different from my node. Let me see. Why is that? You know what? Here, I'm gonna cheat. Okay, I'm gonna cheat, and I'm gonna go in the test file of the universal router, because this is how I was able to prepare this trading bot today. So this is the repo for the universal router, and they have a test folder. Okay, and in this test folder, this is very interesting because you can see the different test case for different scenario. And so here you have v2 exact in permitting the exact amount. So this is what we want. And here, basically, yeah, they do. Okay, this is the interesting part. Planner add command v2 exact in. And so let's visit the file where they do exactly this. So planner add command. Yeah, here add command. Okay. And we can see the ABI here. ABI definition. So v2 swap exact in. Let me see. Yeah. Yeah, it is this one. v2. Yeah, so we just copy this. All right. Then, so we have these two things. Now we need to define the input. Okay, and after that, we will be done. So how are we going to define the inputs? Let's do this. This is going to be an array. And in this array, we're going to have two nested arrays. So the first one, the to input, is the permit object that we have. Let me see. We have defined here with the signature. Oops, sorry. With the signature. And after that, we have another array. So wallet.address. And by the way, you can see that the inputs here match the ABI. So here, permit, the permit struct plus the signature. And the other one, for example, wallet address. First, we have the address. I mean, yes, this is, this matches. Oh, oops, here there's a little mistake. Let me fix this. Let me see. Yeah, should be correct. Like this. Oh, no, here there's two. Yeah. All right. So, yeah, after that, it's the token in amount. After that, token. So here, this is the minimum amount that we are going to receive in output. So we need to know the price. We need to know the current price of the token, but we can actually have an approximation of that because we have the information about the transaction that we are copying. So we can just calculate the price easily by getting by extracting the two different amounts. Okay, amount in, amount out. Okay, amount in, amount out. So how are we going to do that? Well, swap. Let's check for the swap events which amount is equal to 0, and based on that we know what is the amount in. So if this one is equal to 0, then for sure the next one will not be equal to 0. Okay, otherwise this one is correct. And for the amount out, it can only be 3 or 4. So same thing. If 3 is 0, then it's 4. Otherwise, it's 3. All right, and now let's go back to here. So token in amount, let's multiply this by the current price. So how are we going to do this? We're going to do amount out divided by amount in, but we also want some tolerance, okay? Because we might receive less than this because of slippage. So let's have a 5% tolerance. So we multiply the top by 95n, which is how to convert 95 to a big number. But we need to divide the bottom by 100 in this case. All right, so now we have our tolerance, and after we need an array with the address as input and as output. Token out is basically we are copying the trader. And then the last parameters, I'm not sure, but I believe, so where I copied, the variable was source MSG sender. I think it means if the recipient of this swap is the same as the sender. Not sure. All right, and so with this, we have our two inputs. So now inputs 0 and input 1. And yeah, and that's pretty much it. So I'm not going to test it because this will do some real transaction on mainnet. So if you want to test it with the swap, so we saw that before the swap it was working, right? Up to here it was working. If you want to test also this part, what you could do is do a local fork of mainnet, and you can do this by using Envol, which is a local blockchain part of the Foundry, the Foundry framework. And basically, on this local fork, you basically activate God mode. Like you can have as many tokens as you want. You don't spend real ether, but you can test against the data of mainnet. And in some other stream, I show how to do that. Okay, in the sniping bot video, actually, you can check it as one of the previous stream. I show how to test against a fork of mainnet. But for today, I think it was already quite long, so we're gonna stop here. But you can see that this bot, the code is actually pretty complex. Even though the business rules that we have are pretty simple, we're just going to copy all the purchase of a specific person, of a one or several address, but that's it. But you can make it way more complex. What I would recommend to get started, to be really practical, is maybe not to do the purchase automatically, but just send, maybe save this either on a CSV file or on a Google Sheet, or send email, and then you can analyze the trade yourself to decide if you want to do them or not. All right, and so before we stop, so quick reminder, we do a Solidity bootcamp, okay? So eattheblocks.com/bootcamp. The next cohort start next week. So today is the last day to enroll. All right, let me see if there is any last question in the chat. All right, did you guys like it? How did you find it today? Like, was it too easy, too hard? How was it? I had to do a lot of research for that. Okay, so that was clearly not a vanilla tutorial, especially the part on Uniswap v3. It's not easy. All right. Well, I see nobody in the chat. So thanks everybody for coming today, and I will see you on another stream. All right. Bye everybody.